Yo, what is up, you AMs, you Gooners, you Fediverse users, you beautiful, beautiful people? It is your boy, Christiano Valerian. Sorry, but I've done that again. And this is my video assignment for the CNN implementation in big data sets. It's your boy, Christiano Valerian, 23K4001. CNN. What is CNN? It's not that the fucking cable news thing. CNN, convolutional neural network, is basically the merging of neural networks with convolutional systems. Neural network, as you know, is a model, is an artificial intelligence model that is modeled after the functioning of the human brain. And convolutional network just means it's convolutional. It's convoluted. It's crazy out here. It's crazy, man. It basically means that convolutional systems uses like multiple parameters in order to be able to identify things, specifically images, in which the implementation is today are images. I want to preface this by saying I'm really sorry, Mr. Ansel. I know I've been slacking, but this is my video assignment, and I think you'll like it. So, first, I want to explain what is the dataset. The dataset I'm using today is the Simpsons characters data. The Simpson characters data, which is a compilation of images pertaining to characters of the hit show The Simpsons, or The Simpsons, the yellow, cheesy-looking, abominations of Earth, which is posted by Alexia or something. Posted by user Alexadia about 6 years ago. It's actually quite a large data set. It's about a gigabyte large, and so the data set has a couple parts. So we got here Google Simpson test here, a bunch of random images. You got the Simpson dataset itself, filled with labeled names on the thingy. Yeah, cool. That's a dataset. It's quite a large dataset filled with images. And how is it going to affect the CNN method? So the convolutional system is really infamous for its usage of scanning pixels. It scans the RGB value of pixels, and it creates what the method called a pool, which basically it averages a couple of pixels into one sort of data to make it even simpler. And so, because lots of the Simpsons are yellow, I think the edge detection, which is another CNN thing, would be a little hard, but as you'll see later, it actually kind of works. Okay, 2. Let's look at the code. Oh my Lord Jesus. Someone just died. It's my remote. Okay. Let's look at the code. So this is la code. It's kind of a mixed match of some stuff I find online and a bit of an AI. But it's mostly by this person, by Gulov Ilya, about a month ago, 35 views. Okay, cool. They basically use the dataset, use CNN, basically make an image classification thingy. And it's the code. I put it up on Colab. It was a hassle to put. But it has your stuff, you know what I mean? Your stuff. So this is your data source mapping, yada yada yada. This is the stuff that you actually need to use to the CNN. And then I think the preprocessing is somewhere. Is the preprocessing okay? Cool, but this is the code. It's actually pretty short. That's kind of cool. But yeah, that's the code. If you want to see the code, Mr. Anso, you can look in the description. I'll give you my Colab notebook. But now it's time for the next one, which is the architecture. The usage of architecture in CNN Architecture is defined as an architecture. It's basically a system in which the convolutional system would use, the network would use to make decisions, right? So you got things like AlexNet. Okay, so here's just a bunch of examples of what architecture would look like if it was in topographical fashion. But you got things like AlexNet, you got things like other types of nets. Even Google has their own like image classification architecture. But those aren't really mandatory. You can actually make it on your own, and that brings us to the point of this video, which is architecture I'm using. The architecture I'm using, surprise, surprise, drum roll please, it's called SimpsonsNet. Wow, so cool. SimpsonsNet, so creative. Okay. SimpsonsNet. SimpsonsNet is a original architecture made by the previous code owner, and so might as well just use it. You know, you don't really have to use AlexNet or any other conventional architectures that we use. So here's SimpsonsNet. It's actually quite short. It's not actually that big. It's actually not that big of an architecture, but it works. You know what I mean? Okay, so here's a video of it running. I'll describe it a little bit. It actually took a while to run this thing. It was, goddamn. There are, I guess you could say like two, main processes. Yeah, there was the training one. Wait, no, there is no training. No, it's straight up to the training. Yeah. But the training actually took a lot of time, and it's mostly because it has so many images, and I think the problem with it's that I'm using a free version of Google Colab, which actually has a computing limit. You can only use their premium GPUs for so long, but I don't. But my student account doesn't really have a premium Google Colab, which is totally fine. So it took about 3 hours before it started literally stopping, which was unfortunate, but it doesn't really mean anything. It just means that it stopped at. So I took 10 epochs, and I know that it doesn't sound a lot, which it isn't, but it actually took a very long time. I tried a couple of other architectures, it just didn't seem to work for me. So this SimpsonsNet took 3 hours with 9 epochs completed. And so I can't really calculate the correctness of it, but as you can see here, the loss has sort of decreased. It kind of evens out, I think. Average time of 13 minutes per epoch. It was freaking crazy. And the accuracy, I gotta say, pretty nice. At epoch 1, it's a bit, whatever. Epoch 2, no, sorry, this is epoch 1. I guess, I don't know, I don't really care. The value is 2, the training accuracy is 2.574, and the VALAC is 0.4436. It's off to a really bad start, I gotta say. It's your first day. Whatever, off to a bad start. Let's go to epoch 002, 0.5 in the training accuracy, and the evaluation accuracy of 0.6. What? Crazy. Okay. And then it started to grow and grow and grow until you got the accuracy of 0.97 and 0.78 of the value accuracy, which I think after 0.75 is pretty good. I don't have to be cheating to use your own architecture for this specific, but that's kind of the point, right? It's kind of the point of making your own architecture for this type of stuff, because what else are you gonna use it for, man? Yeah. So that's the thing, I guess. That's the thing, and this is, oh god, sorry. This is the result. So there's a code here. Let me actually. Yeah. Sorry, Jesus. Okay, so I ran a little bit of code here so that it would grab random characters and then it would put it into the model and then it would find out what the character is. So let's just run it. Okay, cool. Here you go. We got a couple images here. 3x3 matrix. So we got Chief Wiggum, Mo Silzak, Apu, whatever, Principal Skinner, Sideshow Al, Krusty the Clown, my husband Hooting, Charles Montgomery Burns, Principal Skinner. And if you're a Simpsons fan, you probably know all these, right? But the thing that I'm most interested is the product. And if you don't know convolution networks, it kind of transforms the pixel data a bit so that it basically like saturates it so that it can find it could have the edge detection, as you can see here. Look, so the edges are very contoured or more matte, I should say. Let's run this a couple more times. You know what I mean? Bart Simpson, Sideshow Bob, Lisa Simpson. So a lot of times it's correct because it has its own architecture and it's pretty much a lot, like, really accurate. Okay, this one's 6, a bit longer. But yeah, cool. And even with things like text and like background things, it handles it pretty well, actually. So, that is my CNN implementation. I know it's not as good as the others, you know what I mean? Because the others, like, oh, look at me, I'm using X-ray images. Look at me, I'm using fish images. So yada yada yada. But it's not fun, you know. Yeah, I think CNN should be implemented in a more fun way, like The Simpsons. No conclusion. That's it. CNN is cool. It's really cool image classification, and I guess the other implementations are if you got a camera, they could do some really cool shit. I don't know. But that is all for me. Thank you so much, Mr. Anto, for your patience, and peace out!